Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 15, the division algorithm, converting decimal division into whole number division using mental math. Okay, so for starters, the division algorithm is simply if you have a number such as 20 divided by 8, the division algorithm simply means to draw it out this way and do the long division. That's the division algorithm. There's an example for you. So 20 divided by 8 is 2.5. Okay. Okay, just had to fix my pen there. I had to sharpen my pencil. It was a little bit dull. So here we go. Use mental math to evaluate the numeric expressions. All right. So instead of taking this number here and saying 99 plus 44 and say 9 plus 4 is 13, carry the 1, 9 plus 4 is 13, plus 1 is 14, we're going to use what they call mental math, which means do it in your head. And in order to do that, we approximate and rearrange things so they're easier to picture in our head. So it's really easy to add something, to add to a 100. So I'm going to change 99 to 100. But in order to have done that, what I have really done in my head is added 1. Why does it keep doing this? Okay. Add 1 to 100, 99 to get 100. Well, I can't just add 1 to a sum because I'm going to be off by 1. So if I take 1 away, okay, then I'm going to get 100 plus 43. And that's easy. That's 143. So if you add 1 to 99, you have to subtract 1 from 44, so 100 plus 43. And that just makes it a lot easier. Okay? So in this one, let's say 86 minus 39, if I increase both by 1, if I have 87, and the reason I'm increasing both is because this is subtraction. So if you increase 86, that's adding 1. If you increase 39, that means you're subtracting 1 more, which is 40. So you're really decreasing 39 to negative 40, if you will. Because 86 minus 39 is saying 86 plus a negative 39. So if I add 1 to 86, I get 87. And if I add 1 to 39, I'm really subtracting 1 to get the negative 40. So when I say add 1, it's really adding a negative 1. So 86 minus 40. Well, that makes it easy because we have 0. So 8 minus 4 is 4. 7 minus 0 is 7, so it's 40. Okay? 50 times 14. Now with multiplication, if we double 1, okay, so with multiplication, if we double 1, okay, divide the other by 2. So let me explain that here. So if I multiplied 50 times 2, and I multiplied 14 by a half, which is the same as dividing by 2, 14 divided by 2, or if I divide it by 2, then I have multiplied by 2 here, divided by 2 here, and 2 divided by 2 is 1. And whenever we multiply by 1, we get the same answer because that's called the multiplicative identity. So if you multiply by 1, you still get the same number. So for some reason this keeps going to that. So if I double 50, that would be 100 times, so I doubled 50, I multiplied this by 2, so I will divide this by 2. I'll divide this by 2, so half of 14 is 7, and 100 times 7 is 700. So that just makes it really simple. So 50 times 14 is 700 as well. Okay, but it's a little bit different with division, because if I think of 180 divided by 5 this way, then if I do something to 1, say multiply that by 4, then I'd have to multiply this by 4, because anything divided by itself is the same as multiplying by 1, and it's still the same thing. Okay? So we're going to, with division, we're going to divide both by the same value. So if I have 180, if I double it, 180 times 2, so I'm going to multiply by 2, multiply by 2, that's 360, and divided by doubling 5, we get 10. And the reason I doubled it was because of this 5. It's really easy to divide by 10 because all we have to do is cancel out the zeros. So the answer is 36. Okay? So that's all supposed to be mental math. Do it in your head. If you see divided by 5, double it to make it 10. If I double that, I must double that. 360 divided by 10, drop the zeros, you get 36. Okay, those are a few little tricks for addition, subtraction, multiplication, and division of mental math. Okay, so now let's move on to the next problem. And it says, use mental math to evaluate 105 divided by 35. Okay, so if I double both of these, so if I write it this way, 105 divided by 35, and I double both of them, so I multiply by 2 over 2, then I get 105 times 2, which is 210, and I get 35 times 2, which is 70. Cancel out the zeros, and everybody should know that 21 divided by 7 is 3. Okay? Okay, so now in class, after they had taken some time to do these on their own, then we went over them, so we saw if they were able to do mental math too. Some of them are a little more tricky than others, but I see 77, and I'm thinking 7, of course, and then I say, oh, well, 7 will go into 14 as well. So the magic number here must be 7. So let's divide both by 7. So if I rewrote this as 770 divided by 14, okay, and I divided the top and the bottom by 7, okay, 77 divided by 7 is 11, and don't forget that 0, so it's 110. And 14 divided by 7 is 2, and half of 110 is 55. Okay, here's another 5. If you remember from our example, let me go back. Here was our 5 right here, okay? And when we had a 5, we double it, so we get a 10, so the zeros cancel. Okay, so we're going to do the same here. So if I have 1,005 divided by 5, and I multiply the top and bottom by 2, I get 2010, 2010, 1,005 times 2, and 5 times 2 is 10. Cancel your zeros. 201 divided by 1 is 201. Okay. Now sometimes it's not so clear. An 8, I double it, I get 16. That's not real helpful. Divide it by 4, that's not real helpful. 8, the factors of 8 that go into 1,500, the only thing is 2. So when we run into problems like this, I guess the best way would be to just divide by 2. So I'm going to rewrite this as a fraction. And I'm going to divide by top and bottom by 2. So half of 1,500 is 750, and 8 divided by 2 is 4. So I can still divide that by 2 over 2. Okay, and I shouldn't write it like this because dividing by a fraction, we have a rule that says multiply by the reciprocal, and that would be times 2 over 2 and get us back to where we started. So I'm just going to write it like this, divided by 2 up here, divide by 2 down here, and that is going to give me half of 750, which is 375, and 4 divided by 2 is 2. Okay, and then one more time, 2 goes into 3 once, the remainder of 1. 2 goes into 17 8 times. 8 times 2 is 16, the remainder of 1. And 2 goes into 15 7 times, the remainder of 1. So 2 goes into 10 5 times. So 187.5. So this really wasn't mental math, it's just dividing by 2 multiple times. Okay? So in order to get from 8 to 2, we had to divide it by 2 twice. Half of 8 is 4, half of 8 is 2, and then divide by 2. So you're dividing by 2 3 times. Well, I guess it could be mental math if you think of it that way. Because 8 equals 2 to the 3rd power. because 2 to the third power means 2 times 2 times 2. So if we want 8 to go away and become 1, we divide it by 2, divided by 2, divided by 2. So do the same with 1500. Okay, number 4. 1,260 divided by 5, there's our magic 5. 1,260 over 5, I'm going to multiply the top and bottom by 2, and 2 times 0 is 0, 2 times 6 is 12, carry the 1, 2 times 2 is 4, plus 1 is 5, and 2 times 1 is 2. So now 2,520 divided by 5 times 2, which is 10, zeros cancel, and we get 252. Okay, so now we're going to evaluate an expression that has a decimal in it, dividing by a decimal. So I don't want to have a decimal or a fraction within a fraction. It's just not. Okay, it's called a compound fraction. I can rewrite this as 175 over 3.5. Well, 3.5 is 3 1/2, which is 7 halves as an improper. So this is what I'm talking about. A fraction divided by a fraction is it's a compound fraction, and we don't want to do that. I mean, it just makes it more complicated. So let's go the other way. Let's get rid of this decimal. Well, how do we get rid of the decimal? Multiply this one, and multiply 5 times 2, and it will go away. So I'll multiply the top and bottom by 2 because of that 5. And 175, 5 times 2 is 10, carry the 1. 7 times 2 is 14, plus 1 is 15. 2 times 1 is 2, plus 1 is 3. Divided by 3.5, 5 times 2 is 10, carry the 1, 3 times 2 is 6, plus 1 is 7. Don't forget your decimal place, so it's really just 7. Okay, so don't think you're going to just cancel out those zeros. Okay, you're now just going to have 350 divided by 7. Well, 7 goes into 35 5 times, and then you just put that 0 after it. Okay, so at this point, the students would have practiced these problems after that example in class. I would have walked around, made sure they were doing things correctly, and then come back up and verify that they had done what they needed to do and answered any questions. Okay, so the first one, I see this quarter. And a lot of them said, well, that's like money, $6.25, and there's 4 quarters in a dollar, so if I get rid of that decimal, I can multiply by 4, and that's what they did. And that is the correct way to do it. So if I have 25 divided by 625, I'll multiply the top and bottom by 4. 25 times 4 is 100, and 5 times 4 is 20, carry the 2. 4 times 2 is 8, plus 2 is 10, so there goes that money, that dollar, now it's a whole number, and carry the 1. And 6 times 4 is 24, plus 1 is 25, so that's 25.0. Right, so let's just get rid of those zeros to avoid the confusion, and just say divided by 25. Well, 100 divided by 25 is 3. Okay, 6.3 divided by 1.5. I'm going to write this as a fraction first. I want to get rid of this fraction down here, and if I double 15, I get 30. And with the decimal, so 1.5 times 2 is 3. So I'm going to double it to get rid of this. So if it ends in 5, just double it. 2 times 3 is 6. Don't forget your decimal. 2 times 6 is 12. Divided by 2 times 5, which is 10. Carry the 1, 0 here. 2 times 1 is 2, plus 1 is 3, and it's 3.0. Okay? And I'm going to erase that 0 just to avoid confusion. Just write 3. Now I can just divide. 3 goes into 12, 4. Don't forget your decimal. 3 goes into 6, 2. 4.2. Okay. And then finally, 425 divided by 2.5. There's another 0.5. So 425 divided by 2.5. Since I have a half, 0.5, I multiply by 2 to get 1. 5 times 2 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 4 is 8. So I get 850. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5, and do not forget that decimal. And again, Do not cross out these zeros because that 5.0 is not going to cancel out a 0 above, so rather than writing 5.0, I'm just going to write 5. And now I can do the division just by saying 5 goes into 8 once with a remainder of 3. 5 goes into 35 7 times, and then I still have that 0 sitting there, so the answer is 170. Okay, so now we have another example, mental math and the division algorithms. We're going to do 2 steps. We're going to use mental math to get rid of a decimal, and then we're going to use the division algorithm to do long division. So if I have 4,564 divided by 3.5, the first thing I want to do is get rid of that 0.5 by multiplying the top and bottom by 2. 2 times 4 is 8. 2 times 6 is 12. Carry the 1. 2 times 5 is 10. Plus 1 is 11. 2 times 4 is 8. Plus 1 is 9. Divided by 3.5 times 2 is 7. Okay, that's step 1. We just did the mental math. That got rid of the decimal, and this is the same as this. I shouldn't say the same as. It is equivalent. These two are equivalent. Now I'm going to take 9128 divided by 7. And I'm going to use the division algorithm, which is simply long division. 9,128. I always like to put a decimal there so I don't forget. 7 will go into 9 one time. 1 times 7. Subtract the differences. 9 minus 7 is 2. Bring down the 1. 7 will go into 21 3 times evenly. Bring down the 2. 7 will not go into 2, so I put a 0 here. Bring down the 8. 7 will go into 28 4 times. And there's no remainder. 7 times 4 is 28. Remainder is 0. So my answer is 1,304. Okay? Now let's get into reasoning. So now we're going to bring in a word problem. So we have this girl, Shelley, was given this number sentence and was asked to place the decimal point correctly into the quotient. We have 55.6875 divided by 6.75 equals 0.825. Do you agree with Shelley? Divide to prove your answer is correct. Okay? So I look at this and I say, well, if I move this decimal 2 places to the right by multiplying by 100, then I'd have to multiply this by 100, and that would move this 2 decimal places to the right. This would be a whole number, and I'd have 2 decimal places, and she has 3. So I would say, no, Shelley should only have 2 decimal places. Okay? So what could I say? Okay, so if we use mental math to look at this, we can round. So 55 is really close to 54, and 6 is really close to 6.75 is really close to 6. So if I round this to an even 6, and I want to find multiples of 6 that are close to this. So 6 times 5 is 30, 6 times 6 is 36, 6 times 7 is 42, 6 times 8 is 48, we're getting closer. 6 times 9 is 54, and 6 times 10 is 60. 60 and 55 are 4 away, or 5 away, and 6 times 9 is 54, which is a difference of 1. So I would actually estimate 55 to be 54, and divide by 6. And when I do that, 54 divided by 6 equals 9. That is in the ones position. It will go in that 9 times, and this says 0.8. So I'm thinking her decimal's off by 1 because it should be 8 point something, not 0.8, because 9 is in the ones position, not the 10th position. Okay, so there's my explanation. I'm just not going to write all of that. So now we're going to divide to prove our answer is correct. So the first thing I would do is take 55,000, or 55.6875, or 55 and 6,875 10,000ths, and divide it by 6.75. 5, and I want to get rid of that decimal, so I multiply the top and bottom by 100. 100 divided by 100 is 1, so I'm multiplying by 1. 6.75 times 100 is 675. 55.6875, all multiplying by 100 does is move the decimal place 2 places. So it's going to move it here. So it's going to be 5,568.75. And same with this. It moved it 2 decimal places here to become a whole number. Okay? Okay. So now we're going to do long division. So it's going to be 675 goes into 5,568.75. Okay, let me change colors now that I can actually do this. Okay, so 605 will not go into 556, and I'm going to put my decimal lined up here, by the way. So this is less than these first 3, so I will not get a tens value, so my answer is true. It's going to start in the ones value. So my estimate was 9, so let's try that. 9 times 5 is 45. Don't forget your 4 to carry. 9 times 7 is 63, plus that 4 is 67. Don't forget to carry your 6. 9 times 6 is 54, plus 6 is 60. Okay? So when this happens, 6075 is more than 5568. This is our indication that the number we chose is too big. Okay? So this is common, and don't be alarmed by this. It happens when we carry. Sometimes we don't know that the number is too large and makes our number down below too big. And it's okay. That's why we do math in pencil. We're going to erase, and we're going to try with a number smaller, which is 8. So let's try 8. Okay, and 8 times 5 is 40. Carry the 4. 8 times 7 is 56, plus 4 is 60. 8 times 6 is 54, plus 6, I'm sorry, it's 48. So did I do this right? 8 times 5 is 40. 7 times 8 is 56, plus 4 is 60, yes. 6 times 8 is 48, plus 6 is 54. Subtract 8 minus 0, 6 minus 0, and 5 minus 4. Okay. Bring down my 7. I have my decimal point there, so the answer is 8 point something. And 6 will go into 16 2 times. So sometimes all we have to do is look at the first digit and ask how many times 6 will go into 16. It won't go into 1, but how many times will it go into 16? And it's 2 times. 6 times 2 is 12. So let's try that. 2 times 5 is 10. Carry the 1. 2 times 7 is 14, plus 1 is 15. And 2 times 6 is 12, plus 1 is 13. When we subtract, we get 7 minus 0 is 7. 8 minus 5 is 3. 6 minus 3 is 3. Always make sure this number is less than this number, or your number was too big. Okay? And 337 is less than 675, so then we bring down our last term, which is 5. And 6 goes into 33 5 times. So if you look up here, that's what they have here. And 5 times 5 is 25. Carry the 2. 5 times 7 is 35. Plus 2 is 37. And that's a carried 3, not a whole 3. So I'm going to fix that. Okay. I just want to carry that 3. 37. 5 times 6 is 30, plus this 3 is 33. Subtract, and we get no remainder. And the answer is, let me use my magic pen for this. My shape recognition pen. So, there's my answer. 8.25. Okay, that is lesson 15. Now go to your problems.